Cool. Let's do this question. Now, we could do this several ways, and one of the similar way one of the ways we could tackle this is trying to see if we can work out an equation by working out in these separate segments, right? Working out that triangle, working out this triangle, and then working out the rectangle in the middle, right? Something like that, right? Which I think is similar to what you may have tried. Transom's a bit weird about that, but let's try it anyway. Let's see how it goes. This probably isn't the best way to do it because we'll get into a bit of an awkward algebraic bit. I'll tell you what I mean. We'll get there. Now that bit in the middle is quite easy. It is h times n, or n times h, whatever you want to say. There it is. Cool. Now that bit's a bit easy. The blue bit is a bit odder. The thing is we don't actually know what that length is. We can't say it's spread out evenly between these two things because it might not be the case. It might be the case that this side here, the left-hand side here, is a bit longer than that right-hand side. Who knows? So let's call it an arbitrary A and call that an arbitrary B. We'll have to give it some letters because we're not sure what it is. Cool. Now, so that area of that triangle on the left will have to be half A times n. You could even say it's an over 2. Same thing. And likewise, that right-hand side would be bn over 2. Right. Now, we can add them together to get the full area of the trapezoid. Now, it becomes something like this. Area equals hn plus, well, an over 2 plus bn over 2. Now, this answer is not satisfactory because the question actually hasn't given us a and b. We've sort of made that up ourselves. So we would like to simplify this and rewrite this in a way that doesn't actually have a and b in it. Cool. So we think of some ways of, how this might work. Well, let's write an equation for a and b from what we can see. Now, here's a little thing here. This length here is actually the same as h, right? That bit there. So we can say something like this. On the side here, I'm going to say a plus b plus k is going to be, oh, no, not k, sorry, plus h is going to be k, right? So what we're saying is that length there plus that length, which is a and b, should give us exactly k. And that's correct because we've defined a and b to be exactly that, right? When we've divided some right-angle triangles in this area. Cool. Let's say we know that, and let's put that on the side. Let's shelve that on the side for us. Because I feel like we could work further on this. Now, here. We can factorize this. We can take out some common factors because I can see n as a common factor. I'm actually going to do something quite odd. I'm actually also going to take out a half out of everybody. So I'm going to take out a half n. But you might say, oh, but there's no half here. Yes, I understand. So it's not actually, a proper factorization, but I'm going to do this on purpose. So I'm going to have to say it's not just an h left in there, it's going to be a 2h left in there to compensate for taking out the half, right? So if you do multiply this in, we do get hn, right? And then here we're left with a plus b, and there we have it. Cool? Now, I can actually rewrite this bit, 2h. We wouldn't normally, but here, I could say h plus h. It just means the same thing, and we're happy with that. And here we see something quite interesting. Pow. Now, this whole thing here equals, well, according to what we just wrote here, as our definition for a and b, it is k. That thing there is k, that yellow highlighted bit. So we can rewrite this whole thing as such. H plus k. And there we have the trapezoid formula, or the area formula, I mean. Cool. That's one way to do it. Another way to do it would be this. Let me just crudely draw that thing again, the trapezoid. That was an H, this was a K, this dotted line was an N, and we don't really need this, the side diagonal bits. But here, let's have a look. I'm going to cut this triangle in an odd way. Let's cut it like this. Here's another way to figure out what the area might be. Right? So if I cut it like that, and I'm working with these two triangles that I'm left with, I'm working with these two separate triangles. So again, I'm just going to color code that as, I'm going to say this one's the blue one, and I'm going to say this one's the red one, just so, you know, for clarity's sake. Right? Now we're cut with two triangles. It's the same trapezoid, but we're just starting work on it from a different kind of angle. Okay, that blue triangle. Oh no, let's try with the red triangle first. You know what? Let red triangle first. What's the area of the red triangle? Okay, that's the height and that's the base. The base is K, the height is N. So the area for the area for that is, area for the red bit is half N times K, or K times N. Or, you know, or we don't even put the fraction in. Either way. Cool, timesing it by a half and dividing by 2 is the same thing. Now, what about the blue bit? Let's flip this around. This thing, the blue bit should be the same as if we had, if I can imagine it. If I turned it around, it can look like this, right? Does that make sense? I've sort of flipped it around. And I could reach something like that. And the bottom bit would be H now, right? So, and up to here, up to there would be N. That height there would be N. So the area for the blue bit would be half NH. All right, so we're working the area out of two triangles. Now, putting that together, the area of the whole thing should be half NK plus, oops, that's not a 1, half NH. We can factorize the common factors out. We can take out the half, we can take out the n, and we have k, and we plus an h, and ta-da-da. And we still get the same formula. And that's another way we can do it. Right? So another way you can think about it is having already seen this equation, and that is the answer, by the way. Having seen that equation, we can also imagine it like this. We are saying that it's k plus h over 2 times n. Remember, it doesn't really matter which order we're doing it in. So what that means is the trapezoid here, the area of this trapezoid would be the same of a rectangle where oh, well, let's not say h and k because that's confusing. X and y, let's say. If that was the average of h and k. So the average point, I don't know, let's try another color, maybe purple. Right? So if I could make an average there, if I could average those two lengths out, right? That would be h plus k divided by 2. That would be the average, wouldn't it? That trapezoid has the same area as that rectangle, as that purple rectangle. Because that would be n, and this length here, up to here, would be some value, would be the average of h and k, which is why we have the h plus k over 2. So that's one way you can think about it if you like to think about that space. But here you are. Here are a couple of different ways we can reach this conclusion. And hopefully that helps. Right, and I think for your for that answer, it's just that first part. If you think about it, it doesn't quite correlate to these triangles, or even if you put them together, they don't actually become a rectangle properly. So that would be how I did it, or how I do it. These would be some of the ways you can get that formula, but you could also just memorize it. But that's how it is. That's the formula. All right, see ya.